Today on How It's Made. Hydroponic lettuce, construction wood, recycling, and fishing flies. Bet you thought the only way to grow lettuce was in a garden. Well, vegetables don't necessarily need soil. They can also grow in water, provided it contains the proper nutrients and fertilizers. That's called hydroponics. This method of growing hydroponic lettuce is called deep pool floating raft technology. It sounds pretty complicated, but it's really quite simple. And it all starts in the germination area with lettuce seeds. To plant them, workers use a steel tray connected to a vacuum hose. The tray has 276 holes, and the vacuum sucks a seed into each one. Next, they take a foam block with corresponding holes called an oasis and position it into the tray. A quick flip deposits a seed into each hole of the oasis. The seeds are coated in clay. Clay holds in moisture to nourish the seed, but also breaks apart easily to let the seed sprout. On the way to the greenhouse, the seeds get their first watering. Then workers set them afloat. The pool of water is about 30 centimeters deep. Technicians continuously monitor and manipulate its levels of oxygen and fertilizer. That's the key to hydroponic growing. The water is never discarded, just topped up to replace what the plants drink and what evaporates. On the first day, they water the seeds frequently. Within a couple of days, the seedlings start to appear. They water and fertilize them. By about the fourth day, there's some significant sprouting action. Again, they water and fertilize the plants. The first leaves emerge on about the 7th day in the summer. On about the 11th day in the winter growth rate is slower because there's less sun. At this point, it's time for the first in a series of transplants. Workers transfer the lettuces from the 276 plant oasis to a styrofoam board that holds more plants, 288. They set the boards afloat in the nursery zone. At about the 13-day mark in the summer, the 20-day mark in the winter, transplant number 2. This time to a less crowded styrofoam board that holds just 72 plants. This gives the plants more light and more room to grow. Workers use a hook to avoid damaging the roots. A plant needs healthy roots to absorb water and nutrients. The last transplant happens on about the 26th day in the summer, the 45th day in the winter. Now the lettuces go from the 72 plant board to a board that holds just 18. By now, the plants have long roots, so they're harder to manipulate. The lettuces go into the production zone, the last move before harvesting. These pools are bigger, so automatic machines move the boards around. This hydroponic system produces 500 plants per square meter, almost 5 times the yield of field-grown lettuce. And it's safer too. There's no need here for pesticides or fungicides, and because it's all indoors, fertilizer can't contaminate the environment. By about the 45th day in the summer, the 75th day in the winter, the lettuces are finally ready for harvesting. Workers cut off the yellowed leaves at the base, then either cut off the roots or wrap them around the stem, depending on how this crop will be sold. Then they vacuum cool each lettuce for longer shelf life. An American engineer has invented a self-mending plastic to use for components that vibrate and weaken. When the plastic tears, tiny capsules inside it also tear, releasing a liquid like blood from a cut. Then a catalyzing agent, also in the plastic, seals the tear like a scar. There was a time when if you wanted to build something out of wood, you had to pick up an axe and go chop down a tree. Thankfully, for city dwellers, all it takes today is a trip to your local renovation center to buy 2x4s, 2x10s, you name it. They start with logs cut from spruce or fir trees. Turning them into construction wood isn't that complicated. First, they soak the logs for about 20 minutes. This removes the mud and softens the bark to make it easier to remove. Next, the logs go through the debarker, a machine with a rotor that shaves off the bark. The rotor has 6 sharp blades that take just 10 seconds to shave a log bare. In the filing room, they regularly sharpen and inspect the saw blades they'll use to cut the shaved logs, straightening them back into shape when necessary. In this sawmill, there are 2 production lines. The wider logs go through this saw. The worker at the controls uses a laser to help him position and reposition each log as he runs it through the saw several times to cut it into as many 4x10-inch pieces as possible. An average log usually yields about 7 or 8 pieces. The narrower logs go through a different saw. This saw first cuts a board off each side, then sends what's left of the log onto another saw. The 4x10s on the first production line go for a second cut called the resaw. They're cut in half into 2x10s. The logs on the second production line end up here in what's called the Canterbull machine. It has 8 adjustable circular saws that can cut the log into various sizes of wood, anywhere from 2x3s to 2x8s, depending on the log's diameter. Both production lines feed to machines that smooth the edges and trim off any defects that can affect the strength or resistance of the wood. Then an automated sorter drops the wood into bins according to their size. Each bin then feeds the stacking machine. From here, they'll put the wood into a kiln to be dried to about 15% humidity. Then they'll grade the pieces and ship them to a lumber yard or renovation store. care about our environment, chances are you separate your recyclable waste from your other garbage and either take it to a depot or put it out at the curb for pickup. But have you ever wondered where it goes from there? When the truck arrives, your recyclables go through their first sorting. The worker puts paper and boxes in one receptacle, glass, plastics, and metals in another. At the sorting plant, the truck dumps each receptacle into a separate area. Then it's onto separate conveyor belts for more sorting. On the paper and boxes line, workers first remove any plastic, metal, or glass that got there by mistake. Then they sort what's left into 3 categories. First, corrugated cardboard, what brown boxes are made of. Second, newsprint. And third, mixed fiber paper such as cereal boxes, envelopes, and greeting cards. On the glass, metal, and plastics conveyor belt, workers first remove the big bulky items such as gallon-sized containers. A jumbo magnet picks up everything metal except for aluminum, which isn't magnetic. Workers then sort milk and juice cartons to one area, aluminum to another. They separate plastics into 3 categories, glass into 2, clear and colored. Once everything's been separated, each category goes into a baler, which compacts it, then binds it with wire like a giant bale of hay. Then it's off to the warehouse until they're sold to a recycler. At the recycling plant, they cut open a bale of plastics, then load everything onto the conveyor belt. The plastics pass through magnets to remove any metal that might have slipped through. Then it's into the shredder. It takes the shredder just 1 hour to shred 2 tons of plastic. All those containers are now tiny little plastic flakes. Next, cleaning by friction and water. Any remaining glass or other contaminants now sink to the bottom, while the lighter plastic flakes float to the top. The dirty water will be chemically filtered and used again. They dry the flakes by hot air, then put them into silos to be compacted. Inside the compactor, it's 160 degrees Celsius. The heat partially melts the plastic, fusing the pieces as they compact. The flakes go through the compactor's perforated inner drum, much like a pasta press, and come out looking a bit like macaroni. They're now officially recycled plastic in raw material form. Next, they're melted, pressed through a screen, then cut into pellets 1/8 of an inch long. They drop into water to cool, then go into a dryer. Factories buy these pellets and use them to make plastic products. This recycling plant takes the plastic flakes it produces to mold warehouse pallets. The mold goes in at 230 degrees Celsius for just about 7 or 8 minutes. It takes just 2.5 minutes to mold a recycling bin. Something to help ensure a steady supply of what the factory needs to keep producing recycled plastic. Still moping about the one that got away? Well, maybe you just didn't use the right fly. Fly fishing is one of the most challenging types of sport fishing, and tying a good fly to the end of your line can make all the difference. In about 300 AD, people began decorating their fishing hooks to mimic insects and small fish. The Macedonians were known to use a fishing fly made of red yarn and rooster feathers. Today, with so many synthetic materials available, the design possibilities are endless. But every fishing fly is still based on that centuries-old technique of attaching bird feathers or animal hairs to a hook. The whole idea is to trick the fish. The fly imitates an aquatic insect or tiny fish, something the fish you're trying to catch likes to eat. The fly maker starts by placing a hook in a vise. Using a tool called a bobbin holder, he winds a wax nylon thread carefully and tightly around the shank of the hook, then cuts off the excess. This fly will simulate a moth-like insect called a caddis, a primary food for trout. A caddis in the pupal stage of its life cycle, just before it transforms into an adult. The fly maker first attaches a special synthetic yarn to create the tail. He secures it along the middle of the hook. He then takes another synthetic material called dubbing to create the body. He spins the dubbing between his fingers onto the thread. The wax on the thread helps it adhere. He winds the dubbing over the base of yarn to form the body. Then he folds some yarn over the dubbing and attaches it with more nylon thread. Then he cuts off the excess. Good fishing flies not only look like the real thing, they also act like it, mimicking the insect's natural movements. When a caddis pupa is ready to transform into an adult, it swims to the surface of the water, then deploys its wings. The shimmering yarn on this fake caddis will give the illusion of the air bubbles this voyage to the surface creates. To simulate the wings, the fly maker uses dubbing made of deer fur. He cuts off the long, coarse hairs known as guard hairs. Then places them into a device called a hair stacker. He shakes it, turns it to the side, then opens it up. All the hairs are now evenly aligned. He measures the length he needs to create the fly's wings. Then he attaches it, leaving a portion sticking out in the front to form the insect's head. Next, he uses a tool called a whip finisher to tie a sturdy knot made of several loops. This caddisfly imposter is now ready to trick some trout. There are thousands of styles of flies. You choose which to use according to what the fish are feeding on at the moment. Fly makers use many types of natural and synthetic dubbings to form and decorate their flies. Feathers, animal hairs, metals, and plastics, often dyed brilliant colors. Tying a great fly won't always snag you the catch of the day, but if you maneuver the fly to make realistic movements in the water, the fish will buy it, hook, line, and sinker.